Hello class, welcome to lesson 1-4, which is all about the distributive property. By the end of this lesson, you should be able to use the distributive property to evaluate expressions, and you should be able to use the distributive property to simplify expressions. So let's start with some vocab. I'm sorry, I'm not sure why it's so small. I guess I didn't fix that. But starting with the first one, we have like terms. Like terms are terms that contain the same variables with corresponding variables having the same power. So a like term would be 3x and 2x. They both have the same variable, they both have an x, and with the corresponding variables having the same power. See how neither of them have a number written up here? Okay? That means they are corresponding and they have the same power. However, if I were to have changed this to 2x squared, these are no longer like terms because over on the left with the 3x, that's an x to the first power, and our 2x squared is to the second power. So that means they are not like terms. They cannot be combined, okay? Let's look at simplest form. Simplest form is when an expression, example of an expression would be 3x plus 2x. There's no equal signs. Okay, no equal signs. And contains no like terms or parentheses. So you can see I changed my 2x to 2x squared. This is the simplest form. There's nothing we can combine because our x's have different powers. Alright, and then the coefficient is the numerical factor of a term. What that means is whatever number is attached to your variable is called a coefficient. Okay, so both 3 is a coefficient and 2. The number 2 is a coefficient. Alright, so let's talk about the distributive property. I'm hoping that this looks familiar for you guys, but just in case it's not, this would be a good thing for you to screenshot and use as a reference later on. I'm going to walk through this process with you on the next example, okay? So example 1, we want to use the distributive property to rewrite these problems. So if we look over on the left, you can see we have 7 times 49, okay? We're going to be looking at a lot of mental math today, trying to make things easy for us to do in our heads. So in case 7 times 49, it's not exactly the easiest thing to do just right off the top of your head. But if we were to do, instead of 49, replace that with a 50 minus 1, because that's the same thing as 49, right? Okay. If we do that, then we can do 7 times 50, which gives us 350. That's much easier to do in our head than 7 times 49. And then we do a 7 times 1, which is 7. We subtract the 2, we're left with 343. Okay? So now let's do that apply that same concept over on the right hand side with 6 times 37. What would be a good way to break up 37? We could break it up into 30 plus 7. Okay? 6 times 30. Okay, 6 times 3 is 18. Add our 0, that's 180. 6 times 7 is 42. 180 plus 42, that is much easier to solve. Okay, so 2 plus 0 gives us 2. 8 plus 4 is 12. We carry a 1, and we're left with 222 as our final answer. Okay, so I don't want you using calculators today. I want to make sure that you guys are using your brains. You have them for a reason. Let's use them. Okay, I want you guys to take a minute and look at this first example and see what you end up with for an answer. Alright, hopefully you ended up with 5 times 15 plus 5 times 10, and 125 minutes as your answer. If not, be sure to ask either myself or a friend. We'd be more than happy to help. Let's take a look at example 2. We're talking about a group of 7 adults and 6 children are going to a University of Minnesota baseball game. Use the distributive property to write and evaluate an expression for the total ticket cost. So how are we going to represent this in an expression? So an expression, remember, we're going to have something plus something else. Well, if we have 7 adults and we have 6 children, okay? So 7 adults need tickets, 6 children need tickets. How much is it for an adult to go to a game? It is, see, we have an adult single game is $5, children's single game is $3, a group of 10 or more single game, and then a senior single game. Okay? So what if it says a group of 10 or more for a single game, but let's actually treat it like we don't have that as an option. We'll do that one in just a second. But if we have 7 adults going, that's going to be 7 times 5, and then for the children, we have 6 times 3. And that's going to give us $2 amounts, and we're going to have to add them together in order to get our total. 7 times 5 gives us 35. 6 times 3 gives us 18. If we add the two together, we're left with $53 to go to the baseball game. However, if we were to do the group rate, let's see how much we would save. So we have 7 adults, 6 children, so that's a total of 13 people, and then the cost is $2. We would end up with the price only being $26. So you can see it's important to pay attention to different rates and stuff, because look at how much money they would save if they were to use the group of 10 or more, use the group rate. All right, I want you guys to take a minute and use the distributive property to rewrite 6 times 54, then evaluate. Hopefully you ended up with 6 times, and then inside your parentheses, 50 plus 4, and a total of 324. If not, ask myself for a friend. Let's look at our next example. We have rewrite each expression using the distributive property. All this is asking is for you to distribute what's on the outside of your parentheses to what's on the inside. So sometimes you'll see people draw lines like this to help them remember to distribute to everything inside the parentheses. This is a really good idea to help you visually see, have I completed the problem yet? So 9 times 2x gives me 18x, and then 9 times 5 is 45, and we have a subtraction symbol in between. So we have 18x minus 45 for our first answer. And our second one, we have a 7 on the outside, and we have 4m plus 3, so I'm going to draw my first little line there. 7 times 4 gives me 28m. I see I don't have a line going to 3 in the parentheses, so I know I'm not done. I'm going to do plus 21. And that is my final answer for that example. Take a minute and see what you get when you simplify using the distributive property on this problem. Hopefully you ended up with 3x to the third plus 6x squared minus 15x plus 21. If not, ask for some help. I'm here. That's my job. Okay? Now let's look at our next example. We have rewrite in simplest form. Okay? So we have a 13m plus 12m. Okay? Another way you can write that is you can pull out an m from each of them, put it on the outside. Then you just have a number plus a number. So 13 plus 12 gives us 25, and then carry down our m, 25m. If you can see, oh, we have like terms here, all we have to do is add the number in front, the coefficients, and you just do 13 plus 12, and you say that's 25m, without rewriting it this way, that's fine with me, okay? Alright, and then let's look at our next one. We have 7 times the quantity of 2x minus 3. Remember, when I say quantity of, that means that it's inside a parentheses, okay? So 7 times the quantity of 2x minus 3 plus 5 times the quantity of 10x plus 6. Okay, I'm going to do my little lines to remind myself I have to do both of those. 7 times 2x is 14x minus 21 plus, then we have a 5 times 10x, that's 50x. 5 times 6, that's going to be plus 30. Now, if I go through, I see I have a number with an x here, a number with an x here, then I have a number and a number. Okay, so let's see if we can combine these. We have 14x plus 50x if I'm combining our green. So that's 64x. When you're doing this, one important thing is keep the symbol that's right in front of it, okay? So that's how I knew I had a positive 14 plus a 50x. And now I have a negative 21 plus 30. Negative 21 plus 30 is going to be plus 9. So I have a 64x plus 9 as my final answer. Drawing the boxes around it, including the symbol in front, really helps you from making silly mistakes. Where if you would have forgotten the negative on the 21, you would have ended up with 51 instead of 9. Okay? So silly things like that can be easily prevented. Now let's take a look at this example and see what you get. Hopefully you ended up with 6n squared plus 15n. If not, be sure to ask for some help. Or go back and watch the previous example again and see if you can figure out what you did. Now let's take a look at example 5. We want to use the expression 6 times the sum of x and y increased by 4 times the difference of 5x and y. It's a lot of words. It's okay to feel momentarily overwhelmed. We're going to work through that, and I'm going to show you that these really aren't that bad, okay? And if they're hard at first, that's okay. Hopefully by the end of the lesson or the end of working on your homework, they don't seem so bad, okay? So part A wants us to write an algebraic expression for the verbal expression. Write the algebraic expression for the verbal expression. So let's underline some important things. We have the number 6, and then we have times the sum of x and y. So the sum of x and y. Okay, so let's just start right there. We have 6 times the sum of x and y. So since I have the sum of x and y together and it's being multiplied by 6, I'm going to use parentheses. I'm going to say x plus y. Okay? So let's go back. Let's double check, does this match? 6 times, okay, so I'm multiplying by 6, the sum of x and y. And I'm adding x and y. Looks good so far. Let's keep going. And let's take a look. We have the second part, which is increased by 4 times. So increased, I'm going to actually just underline increased first. So increased by 4 times the difference, so the difference of 5x and y. Okay, so increased, so our first part right here that we already have is being increased by another number. How do we represent increased? We say that is plus, okay? 6 times x plus y plus, then we have a 4 times the difference of 5x and y. The difference of 5x and y goes together, so that's going to be inside my parentheses. Difference of means I'm subtracting, and you start with the first thing listed. So 5x, oops, that should be an x, and then we have y. So there's our algebraic expression. Now part B wants us to simplify the expression and indicate the properties used. Okay, so let's start. We have 6 being distributed here, so I'm going to rewrite that as 6 times x plus 6 times y, because it wants us to write out each step. Okay, so I have distributed. The next step, what is 6 times x? I can just leave that as 6x plus 6y plus, what's 4 times 5? That's 20x minus 4y. Okay, so we are just multiplying, or you can say substitution. Next, I want to put my x's next to each other and my y's next to each other because those are the things I can combine. So I'm going to write it as 6x plus 20x plus 6y minus 4y. If I do that, I just changed the order, and that was called what property? The commutative. After that, we have 6x plus 20x, and I can either rewrite it as x times 6 plus 20, y times 6 minus 4, and then I could just say I have 6 plus 20 is 26x. You may be asking me why I'm not keeping the x in front and writing it as x26. One good way of thinking of that is in English class you have rules on how you phrase things, right? There's grammar rules that you learn. There's different orders for how you say things. The same thing goes for math. If you write x26, that's poor grammar in the world of math. So we always write the number and then the variable. So 26x. Okay? So 26x plus, and then 6 minus 4 is 2y. Alright? And that is, that last step was substitution. And I forgot, the black step would be considered a form of distributive. I forgot to label that. Okay? Now, it's your turn. This is the last one for you guys to do today on this video. Good luck. Okay, hopefully you ended up with 3 times the quantity of 2x minus y plus 2 times the quantity of 4x plus y. If that is not what you got, show me your work tomorrow in class or ask a friend. Go back and watch the part of the video again. That's why we have these videos, so you can rewind and make sure you fully understand the concepts before you move on. Okay, I hope you guys have a good night, and I will see you tomorrow.